Today we're going to look at how to choose the right indicator in volumetric analysis and how to interpret a pH graph in a volumetric analysis. We're going to look at, first of all, for a strong acid versus a strong base. In this case, because both the strong, either acid or base, can be placed in the conical flask or the burette. In this case, the base is in the conical flask since we began with a high pH, as you can see here, of 14. As we add the acid from the burette, you can see the pH starts to fall. The choice of indicator is less critical since one drop of acid will cause the pH to drop sharply from 10 down to 3. The equivalence point is a pH of 7, and to get an endpoint to occur after that means we can use either bromethymol blue or methyl red, which would give us a good endpoint there in the right spot. Now, if we look at a strong acid versus a weak base, the base should be placed in the conical flask and the acid in the burette. Usually the strong solution is placed in the burette. Note that the base is in the conical flask since we've began with a pH that's high, but it's a weak base because the pH begins at 11.5 rather than 13 or 14 like in the earlier example. As we add acid from the burette, the pH falls. The equivalence point, which is where we get equal stoichiometric moles according to the equation, is just below 5. And this is the reason for this is because the acid is stronger than the base. To get the endpoint, we need the equivalence point to occur after the endpoint, so methyl orange would be a good choice here since its pH changes from 3.1 to 4.4. Note the indicator chosen is to match the pH of the strong solution, which is the acid. For a weak acid versus a strong base, the acid should be placed in the conical flask and the base in the burette. Note that the acid is in the conical flask since we've begun here with a low pH, but since the pH begins around about 4.5 rather than 1, we know that the acid is weak. As we add base from the burette, the pH then starts to rise. The equivalence point where you get equal stoichiometric moles is about pH 9, as you can see here. To get an endpoint to occur after this means we need to choose an indicator which is in the basic range, which means that phenolphthalein up here would be a good choice of a pH changing in around about 8, 9 or 10. So again, the indicator is chosen to match the pH of the strong solution, which in this case is the base. For a weak acid versus a weak base, since both the acid and base are weak, it's impossible to get a sharp endpoint. As you can see here, there is no real sharp drop. Therefore, such a titration would be very inaccurate. To solve this problem, a back titration should be undertaken. Note that while universal indicator is used to measure the pH levels, it should not be used in titrations since there is no sharp colour change as with other indicators. Now, if you refer to the VCA Chemistry Data Book, Table 11, page 11, you'll see there a choice of indicators which you can choose according to the pH range of colour change. Okay, I hope you understand that, and look at this a few times if you need to review it a few more times to get the concepts.